Welcome, my friend. As you settle into the quiet darkness, I invite you to let your eyes close and imagine a gentle journey through the universe, one that begins right here on the soft ground beneath our feet and slowly carries us out into the shimmering reaches of space. Picture a grassy hillside at twilight, dew damp on every blade, crickets whispering in the mild night, and the last golden light fading behind rolling clouds while tiny stars begin to prick the navy sky. The coolness of the evening wraps around you like a soft blanket as shadows stretch and the world settles. In the distance, a river glints, reflecting the first few stars as they appear, and you feel the pull of curiosity stirring within you. Imagine now standing in a dense forest as night descends, the trunks rising like pillars around you, and leaves rustling softly overhead. Between the trees, you catch glimpses of a darkening sky through a canopy that looks almost black-blue, and the smell of damp earth mixes with the sweet scent of pine. The forest seems endless yet intimate, every branch and fern within reach, and above it all, the first point of light appears like a friend arriving. In the stillness, you can hear your own breathing, feel the rough bark under your fingertips, and sense the immensity above waiting patiently to be explored. In another moment, you are walking along a moonlit beach, your bare feet sinking into cool, wet sand as waves lap gently at your toes. The ocean is a vast mirror, turning black as the sun sinks away, only to reveal a scattering of stars reflected in the rippling surface. A salty breeze caresses your skin, and the distant horizon glows faintly, where the last sunlight meets the coming night. Each step leaves a small impression that the tide slowly smooths away, and overhead, the Milky Way stretches like a luminous river across the sky, hinting at the millions of suns beyond our own that share this galaxy with us. As the tide recedes, imagine turning inland and wandering through a wide, open meadow. The grass here is knee-high and silvery in the starlight, and small fireflies float above the ground like tiny lanterns. A gentle breeze moves through the field, bringing with it the earthy fragrance of soil and the distant scent of rain. Above, the sky deepens and becomes studded with ever more stars, some faint and some bright, each one a sun of its own. Somewhere among them lies our home star, the sun, a blazing sphere of plasma that warms our world, more than 100 times wider than Earth, its light traveling 8 minutes to reach us across the vacuum of space. Now let us turn our gaze directly toward that brilliant source of light. The scene changes to the edge of a quiet lake at dawn, mist curling off the water as the first rays of sunlight break over the horizon. You feel the warmth as it touches your face, and watch as golden light paints the ripples and illuminates the clouds. Imagine being much closer to the sun, where the heat becomes intense and the surface roils with loops of incandescent gas. The sun's yellow-white light bathes its surroundings, casting deep black shadows across a barren, rocky world. Mercury, whose gray craters and jagged cliffs are scorched by day and freeze by night. Without an atmosphere to protect it, Mercury's surface bakes under sunlight and cools dramatically under starlight, making each crater rim an almost white silhouette against the dark plains. Drift further outward to Venus, wrapped in thick clouds that glow a pale orange-yellow, obscuring any view of its surface. Down through those clouds, the atmosphere presses like a heavy blanket, and the ground shimmers in an everlasting twilight. Sulfuric acid droplets float in the air, and the ground is cracked and rocky, strewn with volcanic plains. You sense the oppressive heat and the bright light diffused through the haze, giving everything a soft golden tint. Even though the landscape is hidden beneath a veil, the planet shines brilliantly in Earth's sky, known as the evening star, a reminder that not all worlds are hospitable despite their beauty. On our own planet, the moon rises silver-white over a calm, clear night. You imagine standing on its surface, the landscape dusty and gray, covered with fine powder and pockmarked with craters. The horizon is so near you could walk to it, and it curves gently against the blackness of space. There is no air here, no breeze, only silence. The shadows inside the craters are stark and cold, while the plains catch the sun's harsh light. Earth hangs in the sky as a bright blue and white marble, larger than the moon ever appears to us, and you can sense the light leaving the sun, bouncing off Earth, then traveling over a second to reach you on the moon's gray plain. Red dunes now fill your view, the sky tinted salmon, and the ground littered with rocks and dust. Mars spreads out before you, its horizon hazy with suspended fine sand. You can almost feel the grit under your boots and the chill in the thin air. In the distance, a giant shield volcano rises gradually like an enormous island, its slopes gentle and nearly imperceptible. Deep canyons scar the surface, their walls glowing ochre in the weak sunlight. Tiny whirlwinds dance across the plains, lifting plumes of dust that twist and disappear. Above, the two small moons Phobos and Deimos arc through a dusty pink sky, each a jagged, irregular rocks, casting a faint shadow on the ground below. Between Mars and the next giant planet lies a region filled with rubble, left over from the formation of the solar system. Picture yourself floating among a field of dark gray rocks and metallic fragments. Some are the size of mountains, others as small as pebbles. They tumble slowly in the sunlight, their surfaces cratered and uneven. The blackness of space between them is filled with occasional glints, as light reflects off an iron-nickel surface. The stillness is broken only by the occasional faint collision of two fragments, sending tiny chips spinning into the void. As you drift on, the scene changes dramatically. Before you looms Jupiter, a gigantic marble swirling with bands of color, creams, oranges, tans, and reds. Massive storms churn in its atmosphere, the most famous being the Great Red Spot, a storm larger than Earth that has raged for centuries. You can imagine hovering just above the cloud tops, feeling the immense gravity pulling at you, while lightning flashes below, illuminating the swirling belts of ammonia clouds. Jupiter's mass bends space around it, causing its many moons to dance like small jewels in orbit. One of those moons, Europa, shows a smooth, icy surface striped with cracks, hinting at an ocean beneath. Another, Io, glows with the red of erupting volcanoes, its lava rivers cutting across a sulfur-yellow landscape. Further out, you come upon Saturn, adorned with a system of rings that seem impossibly delicate and thin. From a distance, the rings shine like a flat halo of ice and rock. Up close, they resolve into countless chunks ranging from specks to boulders that glisten in sunlight. The planet itself is a pale yellow sphere, banded like Jupiter, with storms swirling in its atmosphere. Moving through the rings is like gliding through a frozen stream of shimmering pebbles. Tiny moons embedded in the rings carve out gaps and waves, casting long shadows across the ring plane. Beyond the rings, Saturn's larger moons appear. Titan reveals a thick orange haze and lakes of liquid methane, while Enceladus vents plumes of water vapor from cracks in its icy crust. Still deeper into the cold, you find Uranus, its turquoise hue emanating from methane gas in its atmosphere. Unlike the other planets, Uranus rolls on its side as it orbits, making its poles face the sun for long seasons. You envision the pale blue-green cloud tops, streaked with faint white bands, spinning slowly under a dim sun. The air here is bitterly cold, far colder than anything on Earth. The rings of Uranus are dark and thin, faint arcs of dust and ice barely visible against the black background. Its moons, like Oberon and Ariel, are cracked and cratered ice rock spheres that reflect the cold light. At the edge of the planetary realm, Neptune appears as a deep cobalt disk, its atmosphere whipped by supersonic winds. You see thin white clouds moving swiftly across a dark blue background, and the faint shadow of the great dark spot, a massive storm. The cold here is almost unimaginable. Your breath would freeze instantly if you could stand there. Neptune's moon Triton circles backward and sprays geysers of nitrogen ice from its surface. Beyond Neptune lies Pluto, once considered the 9th planet, now known as one of many dwarf worlds in the Kuiper Belt. Pluto's surface gleams with patches of red and white, mountains of water ice rising above plains of frozen nitrogen. Its companion Charon is so large relative to Pluto that they orbit a point in space between them, a double world sharing its dance at the fringe of the solar system. Leaving the familiar planets, you travel into the Kuiper Belt, a broad band of icy bodies encircling the sun. Imagine moving through a field of dark, dirty snowballs, their surfaces pitted by impacts and coated with organic frost. Occasionally, one develops a tail and bright coma as it nears the sun, becoming the comets we see streaking across our night sky. The space between these objects is vast. You can glide for hours through nothingness before another block of ice comes into view. Farther still, at a distance where the sun is only a bright star among many, lies the Oort cloud, a shell of comets enveloping our solar system. Its members are frozen relics, lumps of rock and ice, that gently orbit in a sphere around the sun. If you could travel at the speed of light, reaching this cloud would still take almost 2 years. Beyond the Oort cloud, the sun's influence wanes, and the stars become your only landmarks. The nearest of these is Proxima Centauri, a dim red dwarf glowing like a tiny ember in the blackness. It is part of the Alpha Centauri system, which includes 2 sun-like stars. Imagine approaching this star, seeing its faint light grow until its small disk becomes visible. The light that touches your skin here is tinted red, softer than the yellow light you are used to. Even though this star is the closest to us beyond the sun, traveling there at light speed would take over 4 years, and so you appreciate the vast separations between even neighboring suns. Moving onward, you come to Barnard's star, a solitary red dwarf with a subtle glimmer. Nearby is the binary system of Sirius, where a bright white main sequence star and its dense white dwarf companion dance around each other. You pass Wolf 359, Ross 128, and many other dim stars whose light seldom reaches Earth. Each star is surrounded by its own retinue of planets and belts of dust. As you drift through this region, you see fields of interstellar clouds, wisps of gas and dust, lit from within by the newborn stars forming inside. They glow red and purple, like watercolor strokes on a velvet canvas. Finally, the panorama widens to encompass our entire galaxy. The Milky Way stretches across the sky as a thick band of pale light, composed of hundreds of billions of stars arranged in spiral arms. You see long, sweeping arms, dotted with bright blue star clusters, and dark lanes of obscuring dust. In the central bulge, a dense golden sphere shines where stars crowd together, orbiting a supermassive black hole hidden at the core. All around, globular clusters look like fuzzy balls of light, each containing hundreds of thousands of stars bound together. Between the stars, nebulae shine in colors depending on the gases within. Red hydrogen clouds, blue reflection nebulae, and greenish planetary nebulae, the glowing shells of dying stars. As you look closer within the Milky Way, you sense its enormous scale. The disk spans about 100,000 light years from one edge to the other, and there are between 100 and 400 billion stars in it. Astronomers estimate that our galaxy alone could host trillions of planets, each with its own weather, geology, and perhaps life. Picture the constellations we know from Earth: Orion, Cassiopeia, the Big Dipper, as mere fragments of this larger structure. Each star you see is relatively near. Most of our galaxy remains invisible to the unaided eye, its distant stars blending into the milky glow. The band you see from Earth is merely the view along the plain, peering through the crowded suburbs of our cosmic home. Our galaxy does not exist in isolation. It is part of a small gathering of galaxies called the local group. Within this group, the most prominent neighbor is the Andromeda Galaxy, a graceful spiral similar to ours, but slightly larger. Through a telescope, Andromeda appears as a hazy oval with a bright core, a delicate disk of pale blue starlight studded with clusters. Andromeda lies roughly 2.5 million light-years away, so far that its light has been traveling all that time to reach our eyes. Between the Milky Way and Andromeda are a host of smaller galaxies, the large and small Magellanic Clouds, shining with clusters of young stars, the Triangulum Galaxy, with its loose spiral arms, and many dwarf spheroidals. From a distance, the local group would look like a scattering of pinwheels and fuzzy balls in a much larger cosmic void. Beyond the local group stretches a vast cosmic network. Our cluster of galaxies sits near the edge of the Virgo cluster, a massive conglomeration containing more than 1,000 galaxies. Imagine standing at its center, seeing galaxies of every shape and size, some spirals with graceful arms, others giant ellipticals glowing with billions of old stars. Between them drift faint dwarf galaxies and glowing nebulae. The space between the galaxies is not empty. It is filled with a thin gas and dark matter that we cannot see directly. This cluster is itself part of an even larger structure, the Virgo supercluster, which includes many galaxy clusters spread out over hundreds of millions of light-years. All these clusters and superclusters weave together into the cosmic web, a vast network of filaments and nodes stretching across the universe. Visualize strands of light linking galaxies like beads on a string, with voids of darkness between where few galaxies reside. Each filament is like a sparkling highway, lined with galaxies and clusters, while the voids are like deep black lakes. From afar, the cosmic web looks like frosted glass or lace draped across the cosmos. It is on these scales that the universe's geometry becomes apparent. Great sheets and bridges of matter spanning unimaginable distances, defined by the gravity of dark matter and shaped by cosmic expansion. When you consider how many galaxies there are, the numbers become staggering. Observations suggest there are at least 2 trillion galaxies in the observable universe. Some studies hint there may be between 6 and 20 trillion galaxies in total. Each galaxy is home to hundreds of billions of stars, and all told there may be on the order of 2 sextillion stars scattered throughout the cosmos. You might try to picture this number by imagining grains of sand on a beach. Yet all the grains on Earth's beaches would still be fewer than the stars in the universe. It is a level of abundance that defies our everyday experience, and each star is a place where planets might circle, clouds might swirl, and life might form. As we travel farther, we reach the edges of what we can see. The universe has a finite age. It began about 13.8 billion years ago, and light has traveled to us ever since. However, because space has been expanding, the distance to the farthest light we can observe, the particle horizon, is about 46.5 billion light-years away. Beyond this lies a region from which light has not had time to reach us, hidden behind a curtain of time. The most ancient light we can see comes from a time about 380,000 years after the Big Bang, when the universe cooled enough for atoms to form and photons to travel freely. This light fills the cosmos with a faint glow known as the cosmic microwave background, which we detect as a nearly uniform wash of microwaves coming from all directions. Imagine that cosmic microwave background as a sphere of gentle light enveloping everything, its color shifting from orange to red to the faintest glow as the universe expanded and cooled. This surface is sometimes called the surface of last scattering. Beyond it lies a world that remains opaque to us, a universe still in its infancy, where matter and light were bound together. Today, those photons have been stretched by the expansion of space, so that their wavelengths are now microwaves. If you could see them with your eyes, they would appear as a uniform field of warm red light. The uniformity of this glow tells us that the universe was once very hot and dense, while tiny variations in brightness reveal the seeds of structure that later grew into galaxies and clusters. There is another horizon in the cosmos known as the cosmic event horizon. Because the expansion of the universe is accelerating, driven by a mysterious force we call dark energy, there is a limit to how far we can ever travel or receive signals from. The cosmic event horizon marks the distance beyond which galaxies recede faster than light due to the expansion of space. For an observer on Earth, this horizon currently lies around 16 billion light-years away. Anything beyond that distance will eventually slip out of view, never to be contacted. It is a reminder that our knowledge has boundaries, not because of distance alone, but because of the dynamic nature of space itself. In the twilight of the universe, imagine the fading glow of galaxies as star formation slows and the bright blue stars live out their short lives. Over trillions of years, the gas needed to make new stars becomes scarce, and the cosmos becomes populated mostly by long-lived red stars that burn quietly. The spiral arms of galaxies fade as their gas is consumed. Dwarf galaxies are stripped of their stars by gravitational tides, and black holes slowly grow as they merge. Beyond the event horizon, distant galaxies become unreachable, and their light fades into darkness. Yet for the time being, our view is rich and full, and we can still witness structures from the universe's youth, thanks to the light that has traveled to us over billions of years. To catch glimpses of the earliest galaxies, astronomers deploy instruments like the James Webb Space Telescope. This observatory, with its large segmented mirror and infrared detectors, can detect faint red-shifted light from galaxies formed when the universe was very young. Recently, Webb spotted a galaxy known as MOM-Z14 at a redshift of 14.44, meaning the light left that galaxy when the universe was just around 280 million years old. The telescope's ability to see such ancient objects comes from its sensitivity and the fact that infrared wavelengths can pass through dust. Its golden mirrors unfold like a flower in space, capturing the faint glow of early stars and enabling us to peer back in time. Imagining this telescope floating at a stable point between Earth and the Sun, sunshield deployed to block stray light, one can almost hear the quiet hum of its instruments while it collects ancient photons. As the universe expands, light that started its journey 14 billion years ago has been stretched, and the objects that emitted it are now tens of billions of light years away. The photons arriving from the Big Bang have traveled across space that has grown larger and larger, meaning the distance to the edge of the observable universe is much bigger than one might first assume. Earth itself, with its diameter of about 12,742 kilometers, feels impossibly small against this backdrop. To connect our daily experience with the cosmic scale, think about how it takes light roughly 8 minutes to travel from the Sun to Earth, almost 2 years to reach the Oort cloud, and more than 4 years to reach Proxima Centauri. These times and distances remind us of both the vastness of space and the swiftness of light. Picture yourself now descending into the abyss of Earth's ocean, where sunlight vanishes and the world turns midnight blue. The water presses in, cool and heavy, and your breath echoes softly. Around you drift luminous creatures, jellyfish pulsing with blue and fish with tiny lights. The seafloor is dotted with chimneys spewing warm, mineral-rich water, their surfaces covered in pale tube worms waving in the current. Even here, life clings to warmth and darkness. Emerging from the deep, imagine standing in a polar wilderness, under a sky alive with shimmering green and pink lights. The air is crisp, snow crunches underfoot, and jagged icebergs glow faintly in the low sunlight. Above, curtains of aurora ripple like ethereal waterfalls across the stars, illuminating the icy landscape with gentle color. On a clear summer night, you lie on your back in a grassy field far from city lights. Above, countless stars sparkle, and sudden bright streaks flash. Meteors burning up as tiny bits of comet dust hit our atmosphere. The grass is cool against your skin as the sky sprinkles brief lines of light. Now let us move to a place where stars are born. Imagine floating inside a vast nebula, like the Orion Nebula, a cloud of gas lit from within. Pillars of dark material rise like mountains, their tips illuminated by newborn stars. Tendrils of glowing hydrogen stretch between them, dyed pink and red. In pockets of the cloud, gravity pulls matter together to form new suns. Drift closer to a massive star, nearing the end of its life. Around a dark core, a glowing accretion disk spirals inward, its inner edge white-hot, and its outer regions red like embers. You sense the powerful gravity and see the swirling chaos of matter, funneling into darkness. Finally, imagine a far future night on a planet orbiting a faint red star. The sky is dark with few bright stars. The Milky Way's spiral long unraveled. You walk along a rocky plateau under a dim reddish glow. In the distance, a white dwarf flickers weakly, an ember among the blackness. Even in this distant epoch, there is texture and light, though faint, and a sense of continuity. Imagine standing on a desolate plain, under a vast sky, when suddenly a nearby massive star reaches the end of its life. The star swells, and then erupts, shedding its outer layers in a cascade of light. A shockwave rushes outward, a glowing shell of gas expanding into space. Colors erupt. Brilliant white at the core, deep blues and reds at the edges, and the sky lights up brighter than 1,000 full moons. Shadows dance across the ground as the gas clouds billow and twist, like smoke in slow motion, seeding the interstellar medium with heavy elements that will become new worlds. Think now about walking on a rocky planet, circling a cool red dwarf star. The light here is dim and tinted crimson, casting the landscape in shades of rust and violet. The sky is darker, stars visible even during the day, and perhaps a larger planet rises, its rings faintly reflecting the red starlight. The ground underfoot is rough and cratered, and on the horizon jagged mountains rise like serrated teeth. Pools of exotic liquid shimmer, reflecting the crimson sky. Even in this alien environment, the play of light and shadow is comforting and familiar. Now imagine you are looking down upon Earth again, seeing continents, oceans, deserts, and forests spread out like intricate patterns. The planet rotates slowly, clouds casting shadows on the blue and green surface. In the polar regions, ice glows white under low sunlight. In the tropics, storms swirl like miniature galaxies, their spirals echoing the structure of the Milky Way. From orbit, you watch city lights come on as night falls, tracing the outlines of coastlines. The bright flashes of lightning and the dark of moonless oceans create patterns of contrast. Despite the enormity of the universe, here is a place filled with life, color, and texture. As you descend through the atmosphere, you see mountains rising with snow-capped peaks, glowing pink in the first light of dawn. Valleys fill with mist, and rivers wind like silver threads. The air is crisp and smells of pine and cold stone. Further down, forests of green unfurl, leaves trembling slightly in a breeze. Lakes shine like mirrors, reflecting the sky above. Even in a simple backyard garden, dew clings to spiderwebs, reflecting miniature versions of the world. Everywhere you look, there is beauty in the details. Return once more to the grassy hillside where we began. The stars overhead have shifted, new constellations climbing up the eastern sky. The moon, higher now, casts soft silver light across the meadow, making every blade of grass gleam. Crickets still chirp, and the cool night air feels refreshing against your skin. In the distance, an owl hoots softly. You feel connected to Earth and to the cosmos beyond. Above you, the Milky Way arches like a luminous cloud, and beyond it lie the local group, the Virgo cluster, the cosmic web, and the horizons of the observable universe. Each layer is like a page in a vast storybook, waiting to be turned. Let yourself breathe slowly. Imagine your body lying comfortably, the weight of the blanket, the pillow beneath your head. Hear the gentle rustle of the trees outside, or the hum of a fan. With each inhale and exhale, visualize yourself drifting farther into the softness of your bed, as if you are floating through space. The stars you imagined earlier remain overhead, now slowly fading as your eyes grow heavy. The universe is vast and ancient, yet you are here now, safe and warm, part of its story. As you drift toward sleep, remember that curiosity and wonder are invitations, not demands. There is always more to explore, but for now you can rest. Tomorrow will bring new questions, and perhaps new journeys. For now, feel free to let go and surrender to the dark comfort of night. May your dreams carry you among the stars and through the fields and oceans we visited. If you enjoy these gentle journeys, you might softly subscribe to join me again. Good night.